In this lesson, we're going to be talking about IP addresses. So an IP address is a logical address that belongs to the Internet Protocol, or IP. Now, IP is a layer 3 protocol, and that's layer 3 in the OSI model as opposed to the TCP IP model. So I've got a layer 3 protocol here, and I've got a logical address, and you can see I've got a Wireshark capture. And here are a couple of IP addresses. So in this case, I've got 10.118.10.1 and 10.118.10.2. And you can see they're denoted by 4 numbers that are separated by decimal points or dots. Let's just talk about what that means here. So each of these sections here is called an octet. Why is it called an octet? The reason it's called an octet is because it's actually represented by 8 bytes. And let's take a look at what 10 would look like. Now, before I take a look at what 10 would look like, let me tell you what each digit here represents. This first digit here on the far left is actually going to be 2 to the 7th power, and that actually equals 128. The next one is 2 to the 6th power. That actually equals 64. Then I've got 2 to the 5th power is 32. 2 to the 4th power is 16. 2 to the 3rd power is 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. And 2 to the 0 power equals 1. Let's take a look at what 10 would look like. I'm going to write it from left to right here, which is how you would normally write a number anyway. It's just you have to keep track of which digit you're actually representing. So I'm actually looking for 2 to the 3rd, which is the 5th digit from the left. So 1, 2, 3, 4. And then I've got a 1 for my 2 to the 3rd. I've got a 0 in my 2 to the 2nd place, and then a 1 in my 2 to the 1st place, and then a 0 in my 2 to the 0 place. So that's what 10 would actually look like represented. So I've actually got 4 of these octets here. You can see I've got 10.118.10.1. That's actually how an IP address is created, is using these 8-bit digits or 8 bytes, and each of these sections of the IP address is represented by this 1 byte, which is 8 bits. So now I've got an 8-bit digit, or a byte, or sometimes it's called an octet, and the reason it's called an octet is because it's 8 bits. With this byte, I can represent values from 0 to 255. So if you were to ever see an IP address that looked like this, for example, this would not be an IP address because the maximum value you can have in any one of these places is 255. Now, the other portion of an IP address, the part that actually allows us to figure out which part of the IP address is the network and which part is the host, is something called a subnet mask. Now, typically when you see a subnet mask, it's going to look an awful lot like this. Now, how to figure out which part is the network and which part is the host? Well, you remember in a previous lesson, I mentioned that we had logical addresses, and the logical address allowed us to have a logical network and then a host address. When we're talking about a network mask that looks like this part of the address is the network portion. So that's my network identifier here is 10.118.10. Now that leaves this last one here, so the entire octet here is going to be the host. There's some binary arithmetic or logic that takes place to figure out how you're going to determine which is the network and which is the host. But just keep in mind that you need the subnet as well as the IP address to figure out which part of an IP address is the network identifier and which part is going to be the host. But commonly you'll see this as your net mask And that means that this is your network identifier, and that leaves this one here as your host identifier. So you can have anything from 0 to 255 as your host address in that one octet. Now, not to confuse things any further, but there's actually two other pieces of an IP address that you should know about. When we're talking about a range of addresses, you actually have a network address, and that's the address of the network itself, and then we have a broadcast address. So what do we use a broadcast address for? Well, a broadcast address is where you would send messages that you want to go to everybody on that particular network. So the low end of any particular network is the network address. So in the case of the example that we were using above, this would be the network address, 10.118.10.0. And the broadcast address, not surprisingly, is the very top end. So 10.118.10. Remember, 255 is the maximum value we can have from that 8 bits of information, or the byte or octet. 10.118.10.255 is actually the broadcast address for this particular network. So I can't use those for any host on my network. So actually, instead of 256 addresses, I really only have 254 addresses to use because I need a network address and I need a broadcast address. That's just the way IP works. There's no way of getting around that. You can't actually give a network or a broadcast address to any host, because if it doesn't provide you with an error, if it's not doing any sort of error checking when you set the IP address, then it's just not going to work, because that's not the way the IP protocol works. You actually have to have that network address and you have to have that broadcast address. So you have to leave those alone, and that leaves you 254 addresses for your hosts on this particular network here. So that's IP addresses, and there's a lot of complicated binary stuff when you start talking about subnets, but the basics are you've got 4 bytes that are used for an IP address, and the subnet mask is how you determine which part is the network part and which part is the host part. But that's a little bit about IP addresses.